GCSE Physics. Welcome. Are you excited for a fun learning session? Make sure you have your book and a pen before we start. Today you are going to learn about gas volumes. Gas temperature and volume. If the same number of particles of the gas are forced into a smaller volume, they hit the walls more often, and so the force on the walls increases, and so the pressure increases. The smaller the volume, the higher the pressure, whereas the larger the volume, the lower the pressure for the same amount of gas particles. The smaller the volume, the higher the pressure. The gas particles hit the walls of the container, causing an outward forces that acts at right angles to the surface of the container. As the volume of a container increases, the pressure decreases. Pressure is inversely proportional to the volume of the container. It is sometimes necessary to compress, squash into a smaller volume, gases. This is because gases take up larger volumes due to the spaces between the particles. In order to prevent explosions, it is essential to know that the containers are strong enough to store the gas. For a constant temperature and mass, a change in pressure or volume can be calculated using the equation: pressure 1 times volume 1 equals pressure 2 times volume 2. Gas pressure is caused by the force of the moving particles on the walls of the container. This force is exerted over an area, and pressure equals force, area. By increasing the temperature, the average kinetic energy of the particles increases, and so they move at a higher speed. There are more collisions, and so the particles exert a greater force. Absolute zero is the temperature at which particles stop moving. Therefore, the gas pressure is also zero, as there are no particles moving to hit the sides of the container.